it can be double, it can be pair, it can be anything. Similarly, this value can be anything. So how do you define map? This is key, this is value. Key is integer, value is integer. Over here, key is an integer, and they're saying value is two integers. Over here, they're saying key is two integers and value is one integer. So you can define it as you wish to, that is on you. This is how you define. Okay. Now, if I'm defining the map to be this, for an example, assume you're defining the map to be this. Now I say 1 equal to 2. It means on the key 1, can you please store 2? So this is what it stores internally in the map. Internally in the map, it stores 1 comma 2. Next I say, I don't want to store it like this. Emplace 3 1. So it stores 3 is the key and the value to 3 is 1. It does a similar thing, stores it into the map. Again I say insert, you can also use insert. 2 comma 4 goes and stores 2 comma 4. And this is how you can store all these three variables. Okay, so in this way you can actually store for this particular declaration. And remember one thing, map stores unique keys, very very important. Map stores unique keys in sorted order, something similar to set data structure. Map stores unique keys in sorted order, something similar to set data structure. Okay, now this is the declaration, the second declaration. For this declaration, this declaration, this is the key. So you have declared the key like this, and the value is a single integer. So this is it. For this, it will be storing like, okay, key is 2 comma 3, so this is stored, and the value, corresponding value is 10. Perfect. So this can be stored like this. That's how it generically stores. Okay, I hope that makes a lot of sense. I told you that everything is stored in a sorted order. So this will at first store 1 comma 2, then it will store 2 comma 4, then it will store 3 comma 1. This 3 lines will be storing like this. So again, if you want to explore or if you want to iterate on the map, one of the ways is you start from begin iterator and you go on till end iterator, similar in the vector. Or you do is you say it, you run a for each loop. First time it is here, so it stores in a pair. Next time it is here, it stores in a pair. Next time it is here, it stores in a pair. If it is storing in a pair, this is it dot first and this is it dot second. So first time prints 1 2. Next time goes here, prints 2 4. Next time goes here, prints 3 1. So if you try to do this cout, this is how you can actually traverse in a map and everything is stored in a sorted order of key. In a sorted order of key, not value. Sorted order of key. Remember this. Sorted key is how it stores. No duplicate. It's all uniques. Okay. Now if I want to access map of 1, if I want to access map of 1, it says a value 2. It says a value 2 because at 1 you're storing 2. But if it tries to access 5, will it find 5? There is no 5. So what happens is it says null. But if you want to print it, it actually goes and prints 0 or null. Okay, because it does not exist. So if something does not exist, it gives you 0. Okay. So this is how you can easily access for a key. Now if you want to know the iterator, imagine you want to know where the key 2 lies, the address of it. So again the find function will come over here and say map.find3. So this is where you get it, the iterator. And in order to access this, you give a star. So this accesses this. And if you want the value, dot second. Got it? It gives you the iterator to the this 3 comma 1. Okay, this it is this. So if you give a star, it's the element, and if you give a second, it is the 1. That's how you can easily access this as well. Now over here, if you try to do dot find 5 and 5 is not there, it points to nothing but dot end. End means after the map. After the map. Okay, makes sense? And again, the lower bound and upper bound functions, if you have seen the video in the description, you can understand how lower bound and upper bound works. Okay, and all the other functions like erase, swap, size, empty are same, so I'm not going to explain it again. Next thing is multi-map, similar to map. Only thing is you can store duplicate keys. You can store duplicate keys. Something similar to set and multi-set, as I told you, right? Duplicate keys, but everything in the sorted order. This time you can store like 1 comma 2, and then you can come across and again store like 1 comma 3, right? So you can store duplicate keys over here. Unordered map, again, unordered map is similar, only this portion will go across. It will not store in sorted. It will be randomized. It will be randomized, but it will it will not have duplicate as well. It will just have unique keys. Unordered map will have unique keys, but it will not be sorted. And the difference is like the map works in logarithmic of time, and the unordered map in almost all cases works in constant time. In the worst case, it goes for big of n. Again, this worst case happens once in a blue moon, not always. In almost all the cases, big of 1 is what appears. So as of now, I can say that I have completed containers and iterators. Now this is not required, no need to learn it. Completed containers is big of 1 is what appears. So as of now, I can say that I have completed containers and iterators. Now this is not required, no need to learn it. Just omit this. Now I'll be telling you all the important algorithms, like which are mandatory, like you should know, and all the other algorithms which I will not teach. You will eventually learn while you code, but that are not like those are not important. So as of now, you can just leave it. Eventually, with time, if it's required, learn at that moment. No need to learn it now. So let's move across to learn some algorithms. Now, if I say you that, hey, listen, I give you an array of size like 1, 5, 3, 2, okay, of size 4, and I want you to sort it. So you will be like, let's apply bubble sort, merge sort, selection sort, so and so. But in C++ STL, if you just write the line sort a comma, it's a 4 size. So this actually means the first position, or the first iterator, the starting iterator, and this means the last iterator. A plus 4 actually means this portion, then portion, the last iterator. Again, similar to something like start is included and end is not included. So you write the starting iterator, which is A, which actually points to this, and A plus 4, which actually points to this. So all the elements are sorted. Right after this line, it will have 1, 2, 3, 5. So you don't have to actually use merge sort, bubble sort, selection sort. It sorts that into one line. And if you're using vector, the starting is begin, this is the ending, the starting iterator and the ending iterator. So in this way, you can sort any container, not map, all not map. I'm talking about vectors and arrays over here. Okay. Now, what if I just wanted, like, I had something like 1, 3, 2, 5, and rather, let's keep it like 5, 2. Okay. And I wanted just this portion to be sorted. So I know A plus 2 because this is A plus 2 for sure. And I know A plus 4, right after this is A plus 4. So only this portion will be sorted. So this is how only this portion will be sorted. Perfect. What if I want to sort them in descending order? Imagine you have like 1, 3, 5, and 2. I want to sort them in descending order. So it's very simple. Give the starting iterator, give the ending iterator, the portion that you want to sort, and just write greater end. Yes, just write greater end. And this is nothing but a comparator, an inbuilt comparator, which automatically sorts it, like I'll teach you comparator, automatically will sort it in the descending order like this, in a descending order. You just need to write greater end and it automatically sorts it into a descending order. Now, what if I want to sort it in some other fashion? Because as of now, we know how to sort it in increasing, we know how to sort it in decreasing. But what if I want to sort it in my way? Because going across, you will see that this my way is being used a lot. For an example, we have declared a pair array, and these are the pairs 1, 2, 2, 1, 4, 1. Okay, and I want you to sort according to second element. Like I want you to sort it in order of increasing second element. Please understand. I want you to sort it according to increasing second element. Okay, and if the second element is same, then sort according to the first element, but in decreasing. But in decreasing. What do I mean by that? So as of now, can I say the second element is 2, 1, and 1? So this 2, 1 and 4, 1 are the guys who should appear right at the first. Okay? Because the second elements are 1 and 1. And after that, I can say after that, 1, 2 will appear because of this portion. So can I say that I've sorted according to the second element? But I still have a problem. Now these couple of guys are having same second element. Now if they have the same second element, I want you to sort it according to the first element, but in descending, which means I want you to have 4, 1 at first and then 2, 1. That means among them, I want you to sort it according to descending. So first 4, then 2. And then you can write, so first sort it according to the second. And if there is a group which is having the same second, then among them, sort it according to the first. So this is my way. This is my way. Like it's something like a combination of increasing as well as decreasing. So this is where generically you write the first iterator, the last iterator, and a comp, and a comp. Remember this, and a comp. Now this is nothing but a self-written comparator, a self-written comparator, and this comparator is nothing but a boolean function. Is nothing but a boolean function. So I've written this, but I'll just teach you how to write it. It's very simple. You write boolean comparator, and this is the function. Okay. This has to return a true and a false. This has to return a true and a false. Now go back and see what is the data type that you just had. And the data type, if you see, was pair of intent. Just copy paste and have couple of guys, pair 1 and pair 2. That's it. Have couple of guys. This is the first thing that you'll do. Have couple of guys. Now please understand this, that this is pair 1 and this is pair 2. So forget about the array. Forget about the array. And now think of just two instances where you have two pairs. Where you have two pairs. This is P1, this is P2. While writing comparator, just focus. What have you been set? Sort it according to the second element. So you say, okay, if my P1 dot second is already smaller than second, that means it's true. We are assuming that the pair 1 lies before P2. Lies before P2. That is what the assumption is. The pair 1 lies before P2. And that is okay. If the second guy is lesser than this second guy, I'm okay. They should actually. So they are in the correct order. This comparator says, are two guys in the correct order or not? And I'm saying they are in the correct order. They are in the correct order because this guy is smaller than this guy, and that is what I was said. So if they are in the correct order. But I know one thing. If it's the opposite, if this is the case, I will say they are not in the correct order. Because if I have two guys, okay, and imagine this is 5 and this is 4, and I'm saying P1 occurs before P2, this is wrong. This is wrong. If this second is actually greater than this, I know this is wrong. So I say they are not in the correct order. So what happens is comparator internally says P1 and P2 are not in the correct order. Can you please swap them? So apparently 4 comes before 5. This is what happens. So they do internal comparisons and they swap. So I told them false, they are not. So they will swap internally. But do we have any other conditions? We have. What if they are same? Because that's the only condition that is left. That is the only condition, because if these two conditions do not happen, I know we will come to a point that they are same. I don't need to write a if, because that's the only condition that is left. They are same. Now if they are same, we'll again try to evaluate. I know if they are same, this is P1 and this is P2, and this time it is descending. So if this guy is greater than this guy, it's okay, otherwise it's not. So can I say if P1 dot first is actually greater than P2 dot first, it's okay, because this is what I was looking for. Else I say it's not. If they're equal, it's fine. Even if I swap or do not swap, it's okay. So can I say if it's greater, it's okay. That's what I'm looking for. But if it's not, that's false. Please swap it. If it's not, I need in descending. Can you please just swap it? So you just analyze everything whenever you try to write a comparator. Always analyze everything in terms of two pairs. Don't think in terms of arrays. Just pick up. Yes, I repeat. You just need to do one thing. Just pick up one pair. Just take another pair and try to analyze P1 and P2. That is your job. So we have learned about comparators. So anytime there is my way sorting, you can write the comparators. Just need to write this and you should be done. Just focus on the data type and try to just evaluate two data types and write it. Nothing different. Okay. So this is again one more STL which is very important, which is built-in popcorn. So if number is 7, what is the binary of 7? It's 1, 1, 1. That's the binary of 7. So if I say built-in pop count, it says, okay, this has 3 bits as 1. Generally, number 7 means 0, 0, 0, 0, 0, 0. Like these are the 32 bits inside the computer. In 32 bits, it's 0, 0, 0, 0, 0, 0 and 1, 1, 1. So built-in pop count says how many ones are there or how many set bits are there. So it will return 3 set bits. If this number would have been 6, which is nothing but 1, 1, 0. 6 is nothing but 1, 1, 0. So built-in pop count would have returned 2, the number of set bits. Okay. If the number is long, then built-in pop count becomes built-in pop count LL. Built-in pop count LL if the number is long. Integer will not suffice there. Perfect. Now the last thing, if the number is long. Integer will not suffice there. Pop count LL. Built-in pop count LL if the number is long. integer will not suffice then. Perfect. Now the last thing is, not the last, second last thing is next permutation. Now if I write a string as 1, 2, 3, and I want to have all the permutations of it, all the permutations. So what I can say is, okay, listen, I'm gonna have the string, and I know the next permutation is 1, 3, 2. I know the next permutation, like if I talk about dictionary order, 2, 1, 3. The next permutation is 2, 3, 1. The next is 3, 1, 2. The next is 3, 2, 1. Can I say these are the dictionary, like these are the 6 permutations that you can have. 3 factorial is 6. So if you want to print them, what you do is you first print the first string. Then you say, can you have the next permutation, please? Can you have the next permutation? And it takes you, the string which was this becomes 132. And now you print it. Again, the string now becomes 213. And you print it. Again, the string becomes 231. You print it. Again, the string becomes 312. And you print it. Again, the string becomes 321. And you print it. Right after this, it goes to null. It says no more permutations. It returns a false. If there are no more permutation, it returns a false. And if it returns a false, the while loop breaks. And this is how you can print all permutations of a string. Here's a catch. What if the string was 231? Then it would have started from 231, and the next permutation of 231 is 312, and the next is 321. So it would have just printed like first this, then this, then this, right after this, no permutations. So it's very important that if you want to print all the permutations, you start from the sorted guy. Like you just start from the sorted guy.